All right, let's talk a little bit about ratios and how we go about creating ratios, how we go about using ratios, maybe to solve some of the problems that we encounter. But before we start, let's talk a little bit about creating a ratio. So let's say in our example here that we're given some information that says the number of boys to girls in a class. We're asked to write a ratio in that form, and we're told the number of boys is 50 and the number of girls is 24. First of all, this part is important. The fact that it establishes the order, it lists boys first, says the word to in the middle, and has girls last. That tells us the order that we need to write the ratio in. So when we start the ratio, because boys was listed first, we do need to list the boys' number first. We can't start with the girls' number in this case because we're told we want a ratio of boys to girls. So we're going to go with 15. When we get to the word to, we will use a colon to denote the word to. So we would have 15 colon, and the number of girls would be 24. So we have the ratio of 15 to 24. In this case, though, we would also like to simplify that ratio. So you need to look at this and say, what's the largest number that goes into both 15 and 24? Or if you want to think in terms of math, it's really what's the greatest common factor of 15 and 24? Well, it just so happens 3 goes into both of these. 3 goes into 15 5 times, and 3 goes into 24 8 times. So our ratio would be 5 to 8 written in simplest form. Not that 15 to 24 isn't the correct ratio. It's just like a fraction, we want to make sure we simplify and find anything that's common, and we would divide both sides by that common number. Speaking of that, if you're someone who you don't like simplifying these ratios or things like that, a ratio really is a fancy word for a fraction. And you can certainly think of this, instead of being written this way, you could think of it in terms of this. Really basically the same thing, 15 to 24. You can type that in as a fraction. We've done a lot of work in our classes on using calculators possibly to take 15 divided by 24. It ends up being a decimal, and you can certainly convert that back to a fraction. When you convert it back to a fraction, it should convert back to fraction simplest forms, or 5/8, which if you notice matches up with what our simplified ratio turns out to be. So that starts with the simplifying of the ratio part. Next, let's take a word problem. And in this case, the word problem is going to be the ratio of boys to girls. And the ratio of boys to girls is 2 to 3. How many girls are there if there are 60 students in the class? So we're given a ratio of the number of boys to the number of girls. We're asked to find the total number of girls in the class, given that there are 60 students in this class. There's different ways to do this. I like to look at this ratio right here, and I like to think of that as parts. And in this case, because ratios are often used maybe with recipes, this isn't a recipe in this case, we have 2 parts boys to 3 parts girls. So we have a total of 2 plus 3, or a total of 5 parts. If that's the case, I really want to know how many parts would fit into this. Well, we have a total of 60 students, and if I divide 60 by 5, which was my total number of parts, 60 divided by 5, it turns out to be 12. The other way you can think about that is, if we have 2 boys and 3 girls, we have a total of 5 students in that small group of 2 boys and 3 girls. But we know we have a group, we have 60 students. So the question is, if we have 5 students in this small group, how many groups of 5 students would we have? Well, it just so happens 5 goes into 60 12 times. So with 60 students, we could have 5 groups that would all contain 2 boys and 3 girls. So if we have 12 groups, and each one of those groups has 3 girls, there should be a total of 36 girls in that class. Now, the other way to go about doing this would be to take and write some sort of ratio, and maybe write a second ratio. So the ratio might look something like this. We might start with the number of girls. We're going to write our own ratio. The number of girls is 3. Over the total number of students, well, in this case, if we have 3 girls and there's 2 boys, it would be 3 out of every 5. 3 out of every 5 students is girls. That is supposed to be equal to, if we start with girls on top, we don't know the number of girls, but we know the total number is 60. So now if you look at the numbers we have here, we're really saying 3 girls to the total of 5 in our small group. That ratio needs to be the same, as we're not sure how many girls there will be, but we do know that the total number of boys and girls is 60. Notice both totals are in the bottom, both girls' numbers are in the numerator. So in this case, now we need to somehow figure out what that might be. You can look at some different things here. 5 times what would give me 60? If I'm looking at how I convert from that number to that number, well, that would be 5 times 12. And if that's the case, I need to do the same thing and multiply by 12. 3 times 12 tells me that this missing number should be 36. There's also some algebra ways that you can go about that. We're not going to get into the algebra part of this. It's really looking at some of the patterns and some of the things that are going on to hopefully figure out that missing number. Next problem. We're going to use some sort of recipe here. We have water to chicken stock is what the recipe says. The ratio is 3 to 5. We have a total of 120 ounces of liquid. Liquid being both the water and the chicken stock. So we know that together they form 120 ounces. And the question is, how many ounces of water do you have? Well, again, I'm going to look at the 3 to 5. And the 3 to 5 to me tells me I have a total of 8 parts. And often in recipes they'll say it's 3 parts water to 5 parts chicken stock. And that was determined by the original statement at the top that said water to chicken stock. So 3 parts water to 5 parts chicken stock, which gives us a total of 8 parts. At this point, it would be a good idea to take our total number of ounces and divide by 8. I want to know how big one part is. If there's a total of 8 parts in this liquid composition, I want to take 120, I want to divide by 8, and that should turn out to be, I believe, the number 15, 120 divided by 8. So one part equals 15 ounces, if that's what I just figured out. It says here, how many ounces of water? Water was the part that was 3. We have 3 parts of water, so if this is 3 parts, 3 times 15 says that we should have a total of 45 ounces of water in our liquid composition. Hopefully that makes sense that in this case we said 3 parts and 5 parts, 3 parts of water to 5 parts chicken stock, which is a total of 8 parts. Each of those parts should be equal. We took our total number of ounces, we divided by the parts, 120 divided by 8 says that we get 15 ounces, so one part is equal to 15 ounces. We then went back and said, well, through the first 3 parts should be water, so we took 15 times 3 and said there should be a total of 45 ounces of water in this liquid composition. Again, hopefully that helps a little bit with the ratios and some of the problems you're encountering. Look forward to seeing you later.